Okay, so today we will be talking about the fourth chapter, that is circular measure. So let's get started. Okay, now in this chapter we will be talking about circles, their arcs. Um, we'll be finding out the arc lengths. We'll be finding out area of a sector. We'll see what exactly a sector is. We will see what exactly an arc is and stuff like that. Okay, so first of all, let's talk about the basics of this chapter. That, for instance, if this is my circle, this is the center of the circle, this is the radius of the circle, and then if I make another radius over here and the angle is theta, so this part right here is basically an arc. Okay, this is an arc, and if I talk about this entire thing, if I talk about this entire triangular diagram or shape, whatever you want to call it, this is basically a sector. Okay, so this is what we need to talk about. All right, so first of all, since you guys can see this sector or this arc was being made by an angle. Okay, this was the angle, this was the angle, and it was being made by an angle. So this angle would be very, very important, and we need to understand that in maths, whenever we have talked about angles, either the angle is in degrees or the angle is in radians. Okay, we have two types of units for angles. It could be in degrees, it could be in radians. So that is the first unit. It's 4.1 radians. Okay. First of all, we need to talk about some conversions, that 2 pi radians is basically equal to 180 degrees. Similarly, sorry, 360 degrees. This is 360 degrees and then pi is 180. This is 360 degrees, and then pi radians is basically equal to 180 degrees. This is the first table of conversion, and with reference to this, you can convert any angle to radians. Okay, that would not be an issue. And if you're doing your working on your calculator, if you want your answer to be in radians, you can directly convert your calculator to radians mode, or if you want your answer in degrees, you can keep your calculator in degrees mode. Okay, so with calculator, things are very easy. If I talk about it directly, so to change from degrees to radians, it's just like from changing liters to centimeter cube or stuff like that, because both units are used for measuring volumes, but you need to do some extra working. Okay, so to change from degrees to radians, multiply by pi by 180. Okay, all right, so yes, and similarly to change from radians to degrees, multiply by 180 by pi. That is it. And we are done with this unit. Okay. This is something very simple. When you guys will be using the calculators directly, you won't be, doing all of this. But if, let's say, for instance, some angle is given in degrees and you've been asked to convert it to radians, for that, you just need to use this formula. And if the angle was in radians and you were asked to convert it to degrees, and use this formula. And that is it. Okay. This is the only significance of this unit. And I just did this for the sake of completeness. That is it. If I talk about one quick example, so it says change 5 pi by 9 radians to degrees. Okay, now the angle in radians is given 5 pi by 9. So to change from radians to degrees, what do? We multiply by 180 by pi. So it is going to be 5 pi by 9 multiplied by 180 by pi. So pi and pi would be cancelled, and you can just simplify things over here. We can cancel 9 and 180. So this would become 1 times, and this would become 20 times, and this is going to be 100 degrees. And this is your answer. Okay, so this is how simple it is. If you don't want to talk about the formulas, just use this ratio method, and even then you would get the correct answer. Okay, the formulas are coming from the ratio method basically. Okay, any questions from here? Anything that you were not able to understand? Yes, Rafi and
Mm.
Munja.
Miss, generally we are going to ignore the word radians, right?
Yes. Generally, if you've been asked to find angle, if you've been asked to find, yeah, angle obviously, and if nothing else is mentioned, you will certainly give your answer in degrees. If the examiner is giving you something in radians, or if the examiner is saying that give your answer in radians, only then we will, give the answer in radians. Otherwise, you are right. You are right.
Okay.
Okay, perfect. Now, first unit is done. That it had nothing, honestly speaking, and you won't get to find obviously any question from this part, because this comes in every question in the end that give your answer in radians. So we'll get to practice that later on. For now, let's talk about the second unit, and then we'll talk about past paper questions. 4.2, it says length of an arc. Now, what exactly was an arc? So basically, we have a circle, and then there's a center, and then this is the radius, and then there was some angle theta, and this made this arc. So this is what I've just explained. And about the arc, the question could be find the arc length. Okay, so we have two different formulas for arc length depending upon if your theta is in degrees or if your theta is in radians. The formulas change for that, and this is very easy. Okay, so let's talk about it now. Arc length, think about it as ratio. Okay, if I talk about this angle, this is going to be 360 degrees. So 360 degrees would give me the entire circumference, that is 2 pi r. But I'm not talking about the entire circumference. I'm talking about the circumference that is being made by theta only. Okay, and that is basically the arc. We don't call it circumference being made by theta, we call it the arc that is made by theta angle. So the formula is theta divided by, now it totally depends. If your angle is in degrees, you'll do theta divided by 360 degrees multiplied by 2 pi r. Now this formula is very logical. 360 degrees was giving you the entire circumference, 2 pi r. We're not talking about the entire circumference. We're only talking about the specific arc, which I've mentioned over here. So we will do theta, that was in degrees, divided by 360 multiplied by 2 pi r, and this is going to be the arc length. And if, let's say, this is 2 pi, let's say that your theta was given in radians. So in that case, the arc length is going to be theta divided by. Now I was dividing it by 360 when the angle was in degrees. So 360 is equal to 2 pi radians multiplied by 2 pi r. 2 pi and 2 pi would be cancelled and this would give you r theta. So the arc length is basically equal to r theta, and you will get to see more use of this formula because it's simple. So for some reason in the questions this formula would be used, given that the theta is in radians. That is mandatory. Theta has to be in radians. Okay, if your theta is in degrees and if you are using this formula, you would get the wrong answer. Okay, so I'm just mentioning it over here. This is when your theta is in degrees and this is when your theta is in radians. So that is very, very important. Okay. All right. So this is simple. Then if I talk about one quick question from the book, just so we get to practice something from here as well, then I'll talk about past paper questions because the questions I chose are not very basic. They are a bit technical. Okay. So let me talk about one very basic question then. It says, it's example number 1 from the second unit. A sector has an angle of 1.5 radians and an arc length of 12 centimeters. Find the radius of the sector. Okay. A sector has an angle of 1.5 radians and an arc length of 12 centimeters. Find the radius of the sector. So if you want to think about it, you can say that there's a circle, then there's center, and this angle is 1.5 radians. Okay. All right. Important thing is that here I'm making the circle again and again for your reference. It could be that it is saying that the center of a circle and the sector is being made like this. Okay, so every time the entire circle would not be given. I'm just making the entire circle for your reference. It could be that only this thing is given. So this and this, both of them are same. They are not different. Okay, anyways. Now you have been asked to find out the radius. So what do we know? We know that the arc length is basically, now the angle is in radians. So the arc length is equal to r theta. And what is the arc length? The arc length is 12 centimeters and the angle is 1.5 radians. So 12 equals r is unknown, 1.5 radians, and r is equal to 12 divided by 1.5. So that is going to be 8 centimeters, and this is the answer. So you guys can see, using the arc length formula, we will be finding out the radius. Okay, any confusions with this part? Anything that you were not able to understand?
No, miss, everything's clear.
Okay, what about you, Munja?
I'm okay, ma'am. Thank you.
Okay, all right. You're welcome. Okay, let me take out the questions now. This is basically from the year 2019. It's question number 5 of the paper. And it says, the diagram shows a semicircle with diameter AB, center
Miss,
O, and yes.
Miss, can you tell everything about this question? Like, May, June, or what?
This is basically the May June exam. It's paper 1-1. I added the paper code and everything for the other question, but I could not add it for this one. Let me quickly see. 1 second. For that.
So it's like May, June 11 and 2019, question number 5, right?
1 second. I am just checking that once again. I'm sending you the paper code. It's 9709/12/May/June/19. Okay.
Okay.
Yes, I'm writing it here. I have added the paper code for the other question, but I keep on forgetting this. It's 1-2, and then it's May, June, and then it's 1-9. Okay, here's the paper code. Okay. So the question says the diagram shows a semicircle with diameter AB, center O, and radius R. The point C lies on the circumference and angle AOC is theta radians. The perimeter of the sector BOC is twice the perimeter of the sector AOC. Find the value of theta correct to two significant figures. Okay. All right. So I'm erasing this now. Okay, first of all, let's think about it slowly. So the diagram is basically a semicircle and AB is the diameter. That makes sense. Center is O, okay. So this right here is basically the center of the circle. Here they did not make the entire circle. We don't need it. And radius is R, okay. So that is R. This would also be R. The point C lies on the circumference and the angle AOC is theta radians. That is also there. The perimeter of the sector BOC. Now they're talking about another sector, BOC. So for that, let's just quickly write down this angle. So here you would not only be talking about arcs and circles, but also your prior knowledge that angles on straight or sum of angles on straight line is 180 degrees or 2 pi radians because pi radians, my bad, pi radians. So this is going to be pi minus theta radians. Okay, why am I stating this? I'm not sure about the question for now, but I need to make sure that since they were talking about the perimeter of the sector BOC, they have referred BOC as another sector. So for every sector, I need to have its angle as well. Okay, so if this is theta, if this angle is theta, sum of angles on straight line in radians is pi. So the other angle would be pi minus theta. Okay. Okay, and then it says the perimeter of the sector BOC is twice the perimeter of the sector AOC. That makes sense. So basically, if I talk about the perimeter, now they are not talking about any other thing. They're saying perimeter. They're using the word perimeter, okay? Perimeter of BOC would basically include this, and the entire arc length. Okay, so always remember perimeter means the boundary of the entire shape and not only the arc length. This is basically the perimeter of BOC. Find the value of theta correct to two significant figures. Okay, so this is the question. Yes.
Miss, why did we do pi minus theta? Not getting that.
Because first of all, pi minus theta, I just added that by my choice. It has nothing to do with the question for now. Okay, when I added this, I just wanted to make sure that I have everything about the diagram. I just extract all the information just so when I read the question, I am able to understand it more. Number two, here they referred that BOC is another sector. So when we talk about sectors, we talk about angles which are basically making that sector. Now this is basically theta radians. We are not sure what exactly theta is, but it is theta radians. So if I am interested in this angle right here, I know that sum of angles on a straight line is 180 degrees. And since here they're talking about radians, so sum of angles on a straight line is going to be pi radians. So if I talk about this yellow angle specifically, this is going to be pi minus theta, right? This entire thing was pi, and I've taken out theta and I'm left with pi minus theta.
Okay, Miss, got it.
Okay, perfect. So the rule was basically sum of angles on a straight line is 180 degrees or pi radians. Okay, this is what you need to know. All right, okay, perfect. So let's start off with the question by writing down some stuff. So what I can do is, let's talk about the perimeter of AOC. AOC is basically the smaller sector, okay? So in the perimeter, I have, what do I have in the perimeter of AOC? I have this side, I have this side, because that's also within the sector, or it basically is making the boundaries of the sector. So these three yellow sides are basically included in the perimeter. So AO is R, and AC can be easily calculated by applying the arc length formula. What is OC or CO? What is this one?
R.
Very good. Well done. It's also R. Excellent. Okay. Because we know that this thing is also the radius. Plus, finally, the arc length. So it's very simple. Arc length is R theta. So I'll just write down R into theta, because theta is the angle here, right? So I can simplify this and write it as 2R plus R theta. So this is basically the perimeter of AOC. Now, if I talk about the perimeter of BOC, perimeter of BOC, what is that going to be? Again, R plus the arc length. And how do we find the arc length? Again, the idea is same, is it's R theta. Now, R theta is basically, our theta is basically pi minus theta, right? So I'll write it as pi minus theta. Any confusions with this?
No, ma'am. Thank you.
Okay. So this would
Miss,
give, yes.
Mr. Line OC is being counted twice in the perimeters. So is that
Yes.
going to be fine?
Yeah, that is fine, because here they have specifically mentioned that the perimeter of sector BOC is twice the perimeter of sector AOC. When we talk about sector, this is sector. And when we talk about the perimeter of any shape, we are going to include all the boundaries. Okay. So here we are talking about the sector BOC separately and AOC separately. And then there's this thing that it's twice and stuff like that. Okay. Perimeter
Okay.
is always going to be the entire boundary of the shape, no matter if it's being counted twice. Okay. So this would give you 2R plus R into pi minus theta. I've just simplified it just so it's a bit simple. Okay, now the helping line. It says the perimeter of the sector BOC is twice the perimeter of the sector AOC. So at this point, I need to make an equation. I'll write it down this way. So the perimeter of BOC is equal to 2 times the perimeter of AOC. The perimeter of BOC turned out to be this. It's 2r plus r into pi minus theta, and it's 2 multiplied by the perimeter of AOC, that was 2r plus r theta. Okay. All right. So that is done. Next, what I can do is I can say I have one equation and I have two unknowns. Even the radius is not known. So in maths, we know that in order to have the value of two variables, we need to have two equations. And if you want the value of one variable, then you need one equation, right? So I only have one equation. I need to get rid of this r somehow. And what I can see is I can take r common on both the sides. So I'll take r common and it would give me 2 plus pi minus theta equals, again 2 is already there, r common, and it would give me 2 plus theta. I've taken r out and I can cancel this r with r and I would be left with 2 plus pi minus theta equals 4 plus 2 theta. Now I can do some basic simplification and that is going to give me, I'll take this 4 on the other side. So 2 minus 4 plus pi equals 3 theta, and I've taken this negative theta on this side, so it would become positive. And this is going to give you theta equals pi minus 2 divided by 3. So now, if the question would have said find the exact value of theta, this would have been the answer. Okay, this is what I was talking about the other day. But if it says correct to two significant figures, it clearly means that you need to plug in these values in your calculator and just see what exactly you're getting. So let's just do that. It's pi minus 2 divided by 3. And this is giving me 0.3805. And this would give you 0.38 radians. 1 second, because the units were radians. Okay, let me just write it down here. It is going to be 0.38 radians. This is going to be the answer. Yes. 1 second. Any confusions with this? Anything that you guys were not able to understand?
No, miss, everything's clear.
Okay, Munja, what about you?
I'm clear, ma'am. Thank you.
Okay, perfect. So now we know that by interpreting or understanding the question slowly, we will be able to solve questions. Okay, let me stop the recording because I'll start it again.